Have our formal definition of conjunction. And so, what do we remember about conjunction? We remember that it has this symbol, the one that looks like that, right? And we remember that we said that it's going to look like and, like that. And if we remember the last thing, what does it mean? We know that this denotes end. So let's read this formal definition. So if P and Q, right, because we need two statement variables, or we could call it components, the conjunction of P and Q, which we already defined before, P and Q, denotes P and Q, which we already defined already. So it is true if and only if both P and Q are true. So basically what it's saying is that we need to craft another truth table to show this. And so that's what truth tables are one way of proving a statement, right? We're just proving a statement. And so this is why we learn truth tables, right? Because how are you going to learn how to prove something if you can't even evaluate if the statement is true? So you got to prove that the statement is true to prove that, and you prove all these other statements that are true, and then you can finally prove the big mathematical statement that's being asked. This is probably your second proof already. Right, I'm pretty sure this is the second truth table. So right here it says both P and Q are true if either P or Q is false, or if both are false, P and Q is false. And so feel free to pause the video and try this on your own. If not, then we're going to do it right now. So what is the first thing I told you to do? I told you to write out all the variables for the statement. So statement variables slash, what's the other word we call these? Components. So now we wrote them all out. So that's the first step. So let's define our components. So let's see. What did I tell you to do? I told you to put true and false. And now that we're stepping into a new idea, I want you to know that this is how we do it. So always for the first component, it's only going to be half of that. So you're going to put half true, and then the other half false. This is true only if you write it the way I write it. So this is true if and only if you write it the way I write it. So I'm emphasizing that. If you write true, false, you're going to have a hard time. So I'm going to show you. So half are going to be true. And so I'm going to denote this with this color, so you could just tell. And then the other half are going to be false. So it's going to say false, false. Are you getting what I'm saying? And now we're going to use Q. So right here, let me put P and Q again. Actually Q. So Q is going to be equal to 1/4 of the truths. So 1/4 of the truths are going to be right there. And then, so there's a pattern, huh? And I want you to tell me what the pattern is. So it's going to be 2 to the n. Remember that. And that's for, if you guessed it, it's for the writing true or false for the columns. Let's say 1/4 are going to be false. So let's see right here. So they go true, false, true, false. So I want you to see the pattern. You see the pattern? And so how much is right here? That's 1/2, and that's 1/2, and that makes 1, right? That's 1/4, that's 1/4, that's 1/4, that's 1/4. And how much does that give us? That gives us 1. So I hope you see what's happening. And so why did I say 2n? For every statement variable after the column written down, so this is our column, right? So right here, going down, that's our column. So every 1/2 n is going to be defined by how many statement variables we have. So that's defined by statement variable. So n equals, so I'll put it over here, n equals statement variables. So right here, p and q. So now we define the truths and the falses already. And so this is going to get more clear and more clear the more times we do this. So this is our next problem. It says P and Q. And so what is this our statement says? It says for our proof right here, it says, is it true if it is only true if and only if both P and Q are true? If either P or Q is false, or if both are false, P and Q is false. And so it's only true if and only if P and Q are true. So I'll put it, that's green. So that's true. What do you think this one is? Well, if you guessed it, it's going to be false, right? Or if you read the statement right here, it says if either or, right, or true or false, it's going to be false. And what's the other thing I said? If either P or Q is false, or if both are false, P and Q is false. And so that would be our truth table. And so then we have proved, and so in math we have these three, we put these little 3 dots. And these 3 dots stand for thus. And you can read it different ways, because it means different things, but right now we're going to define it as thus. And so thus we proved. And so I just want you to get the hang of the idea of this, of how to prove. Because the next couple chapters we're going to actually be proving stuff. So thus we prove P and Q. So really basic proof. So we basically solved this problem. But there's one more thing I need to mention. And so let's say this 2n. What does that mean for us? So for every statement variable, this is going to get larger. And so I'll show you right now. Remember when you had we're trying to prove the negation P? You remember how big our truth table is? If you remember, it was only this big. It said true, false, and then that has to obviously be false, and then that next one obviously has to be true. So that was going to be false, and that's going to be true. So what does this mean for us? This is what's happening. So every n statement variable, so what does n stand for? N stands for statement variable, right here, statement variable, or components. So 2n. So let's say I had 1 for n. What does that give us? That gives us 2. So you can clearly see 1 and 2. Alright, let's say it's 2 squared. What does that give us? That gives us 1 2, 3, and 4. Do you see that? And so let's say we had 3 statements, right? And so let me make some space, Q and R. So how would that look like? And forget what's over here, because we don't need to worry about that. Let's say blah blah blah. So what was the first thing we need to do? Alright, the first thing we need to do when making truth tables is do this. Use 2n. So let's see what happens. So we had three statement variables, so that's going to be 2 to the third. So 2 times 2 is 4, 4 times 2 is 8. So we're going to have 1, 2, 3, I gotta write small because I need space, right? 5, 6, and you don't have to write these numbers. I'm just showing you for the sake of understanding. And so what was the next thing that we need to know? So we know that we need 1/2 true and 1/2 false. And so let's show that. And so let me define this a little more better, so that it makes a little more sense. So I explained it this way first, so you guys were like, okay, I guess I could see it, but now I want to define it better with this new table here. And so 2n is going to go down. Right, this is 2n. You see that? So like this. What does it mean to go that way? And so that just means 1 over 2n. Numbers right here. And we have these numbers. So these are the formulas I want you to remember. These two. To define the top part, and this defines going down. So now we're going to write it as true or false. So we're going to write half of them true and half of them false. And you can write any order as you want. I can write true, false, true, false, true, false. But I highly recommend this strategy if you want to be very successful. So I say true, 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 true. And then I'm going to use this color for false. False, 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 false. Alright, you see that? And so now we're going to do 1/4 true, 1/4 false, 1/4 true, 1/4 false. And so we're going to go like this. True, true, false, false. True, true. And what's the next true? False, false. And so you're seeing the pattern, aren't you? And this is going to be 1/8. And so what does 1/8 mean? We're going to have true. And so once you get this down pretty good, we don't really need to write all these extra numbers. And so it's going to take me a while. But true, false, true. So hopefully I don't mess up right here, for the sake of time. True, false, true, false, true, false. And the last one should be false. And so we finally define our truth table and how to see it. And now we just need to do a couple more things. Alright. So now we're going to have the bottom part right here. And that's all false. So that means the statement is going to be false. and that means that statement's going to be true, depending on what it's asking, right? And so that's what I want you to take notice of. This is how you know you did it right. If you did it right, it's going to be all true on top, and then all false right here. You see that? And then there's a little pattern too. It's like a little triangle. So I'm going to go back so you can see it better. It's like making a triangle. So it's not going to be a best triangle, but it's like making a triangle, right? And then we're going to have a triangle right here that says true, all true right there. So that's another way to visualize it. I added another variable. PQR, let's say S. How big is our truth table going to be? It's going to be 1 over 16. And this is going to go all the way down to 16. And so forth, right? And so let's say I'm put one more here. Let's say I want 1 over 32. So we have PQRST. And sometimes you have that on your test. And there's the last one, 1 over 64. So PQRST, let's say U. So that's how big our truth tables can get. And ideally you don't want it that big. So that's the gist of this. Exclusive and inclusive OR. And so what does that mean? Well, let's look at 2 examples and we'll define what exclusive and inclusive is. If a waiter walks up to you, he asks you, coffee, tea, or milk? And you reply, tea. He's going to give you the tea. He didn't give you the option for coffee, tea, and milk, right? That implies to get both. So if a waiter walks up to you and says, coffee, tea, or milk, you're not going to get the whole menu, right? Let's say I go to a restaurant and they offer me beverages. They only give me 1 beverage, they don't give me 10 beverages unless I order 10. And that's a whole different story, right? And so now we have inclusive. It's going to say cream or sugar. So let's say hypothetically I order coffee. And so then he says, cream or sugar? And what does that mean? It means both. It says cream or sugar. Like you want this one or you want that one? Cream or sugar? So it implies that you could have both. And so what's the problem with this? We only define it by the inclusive. So we try to not go to the exclusive phrase, right? Because if you define the exclusive phrase, it really gives you a messy kind of expression to do this, right? About the meaning of the word or. So by understanding it to mean the inclusive, so we try to do this for the most part, which stands for and or. So that's what it stands for, and/or. So that's what the inclusive phrase stands for. And it could be kind of confusing because, you know, and has its own phrase. But that's what it means, and or. That's what or necessary could mean sometimes, right? To express exclusive or, we use the phrase P or Q, but not both. So what we're defining? We're defining the exclusive. And why would we do that? Remember I said we mostly only use the inclusive? In some cases we want to use the exclusive, but we don't want it so it's super wordy, like the example I give you for exclusive, which said coffee, tea, or milk, right? Well, we don't want something like that, so we'll use something like this. And so, in terms of components and statement variables, we use this. So right here, we have something that says P or Q, right? And not P and Q.